Welcome to this journey into one of the most famous ideas in mathematics, why the Pythagoras Theorem works. We start with a simple right angle triangle. Each sides are A and B, and the longest side opposite the right angle is C. Over 2,500 years ago, a Greek mathematician named Pythagoras of Samos discovered something incredible. He realized that if you square the two shorter sides, their areas always add up exactly to the square built on the longest side. In other words, a squared plus b squared equals c squared. This is the famous Pythagoras theorem. But why is it true? Let's see it visually. Here is our triangle again. On each side, we draw a square. One yellow square on side A, one green square on side B, and the big red square on side C. Notice the labels a squared, b squared, and c squared. The question is, how do the yellow and green squares combine to perfectly fill the red one? Watch closely. We slide the yellow square into place, and then the green square. Together they fit exactly inside the red square. No gaps, no overlaps. That's the magic of the Pythagoras theorem. A squared plus b squared equals c squared. A simple equation with incredible power. Let's look at some real examples of Pythagoras theorem in action. We'll start with a small simple triangle, 3, 4, and 5. Notice how the sides form a neat right angle. Now let's build a square on each of these sides. On the side with length 3, the yellow square has an area of 3 squared, which is 9. On the side with length 4, the green square has an area of 16. And on the longest side, the red square has an area of 25. Do you see the pattern? When we add the yellow square area, 9, to the green square's area, 16, we get exactly 25, the red square. So 3 squared plus 4 squared equals 5 squared. Now let's try a bigger example, 5, 12, and 13. Again, we create our squares. Yellow for 5 squared, which is 25, green for 12 squared, which is 144, and red for 13 squared, which is 169. When we combine 25 and 144, the pieces perfectly match the red square. So 5 squared plus 12 squared equals 13 squared. Finally, one more triangle, 8, 15, and 17. Squares go on each side. And just like before, the two smaller areas merge exactly into the bigger one. A squared plus 15 squared equals 17 squared. This isn't a coincidence. It's the heart of Pythagoras theorem. The sum of the squares on the shorter sides always equals the square on the longest side. And this isn't just abstract math. From ancient pyramids to modern bridges to the computer graphics we use every day, and much more. This 2,500-year-old secret is still shaping our world. The next time you see a right angle triangle, just remember you are looking at a piece of timeless mathematical beauty. And here's a challenge for you. Can you think of any other set of numbers that work this way? If you do, write it down in the comments. I'd love to see what you'll come up with. That's the magic of Pythagoras. It always adds up.